Section 4 of Chapter 10 is about Newton's third law, known as the action-reaction law, as well as the law of conservation of momentum. Newton realized that forces are not one-sided. So if you recall, the first law is about an object and unbalanced forces causing it to change its motion. Newton's second law is looking at the relationship between force, mass, and acceleration. His third law is stating that if one object exerts a force on another object, then the second object exerts a force of equal strength in the opposite direction. So for every action, there is an equal and opposite reaction. When you push off the ground to walk, the ground pushes back with an equal force. When we're walking on concrete, we don't notice this as much. But if you walk along a beach, or say you're walking on nice plush carpeting, you can feel the pushback from the floor. When a bird flies through the air by exerting a force on the air with its wings, the air exerts a force back, forcing those wings up so that they can actually lift their wings. So the big question is, do action-reaction forces cancel each other out? And the answer is no. Balanced forces have a net force of 0. And this only happens when all the forces are acting on one object. Newton's third law refers to two different objects acting on each other, so they can't cancel out. So in your textbook, they have this example using volleyball. The first player hits the ball. This player is exerting an upward action force on the ball. The ball exerts an equal but opposite downward reaction force on the wrists of the player. So one force is on the ball, the other force is coming from the ball onto the player. These are action-reaction forces. They cannot be added together because you're acting on different forces, but they also cannot cancel each other out. Okay, so remember that forces can be added together only if they're acting on the same object. Forces can be canceled out only when they're acting on one object. Momentum is a quantity of motion. Momentum is mass times velocity. So the units for momentum are kilograms times meters per second. Notice that this is similar to force, which was kilograms times meters per second squared, or mass times acceleration. Momentum of the object is in the same direction as its velocity. So make sure you don't get these mixed up. So when we look at momentum, the law of conservation of momentum says the total momentum of any group of objects is the same unless outside forces act on the objects. So if you have the same conditions before an event, incident, collision, whatever term you want to use, that same amount of momentum happens after the event, incident, collision. You can't gain or lose or misplace any momentum. So in your textbook, there were different pictures with blue and red train cars. Let's go through the pictures. The first one has car X traveling at 5 meters per second. Car Y comes up behind it at 10 meters per second and catches up and hits car X. The momentum at the crash will transfer because of the third law of motion. Car X now speeds up to 10 meters per second with its additional momentum, but car Y will slow down to 5 meters per second. There was a total amount of momentum of 15 meters per second before the hit. There's still 15 meters per second of momentum after the hit. So there's a transfer there. The second one is when one object is stationary and the other one is moving. Car X is traveling down the track and hits car Y that was stationary. Car Y will suddenly move and car X will stop at that place. The momentum was transferred between the objects. One starts to move, one stops. This happens quite often, and this is what police officers use to measure and determine the speed a car was moving if it rear ends another car. They can literally measure the distance a car moves, the direction the car moves, to know where the impact was. This is really important if someone tries to move their car away and say, I wasn't traveling that fast. They can measure all of that. Now the third one is when the two connect and share the total momentum. They use this in railroad trick areas to connect the train cars to get them down the track. So if car X is traveling and hits car Y instead of bouncing off of car Y, the two cars will connect. That transfer of momentum, and the momentum is still conserved. So if one starts at 10 meters per second and connects to a stationary car, instead of transferring all of it to the second car, car X slows down, car Y starts to move, and they're traveling at 5 meters per second each. Okay, let's look at the section 4 review questions. According to Newton's third law of action and reaction, forces are equal but in opposite directions. Conservation of momentum says the total momentum is exactly the same before and after a collision. Question 3 was looking if you have two people skating together, one has double the mass. When they push away from each other, which one moves further back? And that would be the person with the less mass because they can move faster. You have the same amount of force. Question 4 is comparing the momentum of two animals in the ocean. The dolphin is 250 kilograms of mass moving at 6 meters per second. The manatee is 450 kilograms, but moving at 2 meters per second. The dolphin has a greater momentum. 250 times 6 is 1,500, while the manatee is 450 times 2, or 900 kilograms times meters per second for its momentum.